Hello, welcome to our presentation on the chemistry of taste and flavor. I have here with me Natalia, Samantha, and Jaden, and I'm Victor.
So, a little background on taste and flavor. They're actually caused by many compounds, and 80% of taste is actually experienced through smell. The human tongue picks up five distinct tastes, which are sweet, salty, umami, bitter, and sour. And there are over 1,000 organic compounds that are used to make flavors, which makes it a little more difficult to study. And as many people, as they get older, they lose one of the five distinct tastes.
So first we want to do a short quiz, which is just a question of, do you think an orange or a Jolly Rancher has more chemicals in it? And the answer to this is an orange, actually. So an orange has over 100 volatile compounds, whereas a Jolly Rancher only has a couple synthetic compounds which are made out of. And many people find this really crazy because everyone thinks like an orange is very healthy, which it is for you, but it's made up of many, many compounds. And any type of citrus fruit will have many of these different compounds. And some of the compounds that are put into the orange are ethyl butanoate, alcohols, esters, and hydrocarbons. So next I want to talk about the flavor trend. This is more for like industry and food science companies, and then the industry use learning about the chemistry behind flavors, tastes, the food science industry. People have to take an exam to become a taster since some people don't have the correct taste buds. I actually did this when I worked at McCormick, and it's very hard to pass. You need 90%. And one of the things that people don't pass is when they think that cilantro tastes like soap. And the gene cluster for this is ORA62, and this actually makes cilantro into an aldehyde, and these aldehydes are used to make soap, so some people actually taste the soap instead of the cilantro.
So one of the many compounds that cause flavor and taste are a class of compounds called esters. Esters consist of an alkoxy group attached to an acyl group, like you see on the right there. That is a ethyl acetate, for example. Esters can come in many varieties and quote unquote flavors, including but not limited to octyl acetate, which contributes to the flavor of an orange, isoamyl acetate, which contributes to the flavor of banana somewhat, methyl salicylate, which is wintergreen oil, and more. Now, how are esters made? There are two synthesis schemes for esters. The main one that's used in academia and industry is called a Fischer esterification, where you take an alcohol and a carboxylic acid in the presence of a strong acid like sulfuric acid to catalyze the esterification, and from that you get your ester. And you'll know you've succeeded if you smell your product coming off of it. However, there's another lesser known reaction. It's called the CDI coupling. So you have your carboxylic acid here. It reacts with your base and your coupling agent, and that creates carbon dioxide and imidazole that come off of it. Then you have your intermediate species here, which reacts with your alcohol to form your ester, releasing another imidazole molecule. Now, there's the Maillard reaction, which is a very important reaction in cooking. It occurs between things that are rich in protein and things that are rich in fat. This accounts for, like, for example, some of the flavor of steak and bacon and whatnot, and there are many classes of compounds that come off there.
So we're going to talk about some specific flavors that we found interesting. The first one is capsaicin, and its chemical structure can be found on the side there. And this is actually derived from chili peppers, so it has a very spicy, hot taste. And it's a chemical irritant, and if you had pure capsaicin, it'd actually be toxic. So the way capsaicin works is it binds to a protein called TRPV1, and this causes the channel to open the threshold at temperatures less than body temperature, which is what causes that hot, spicy sensation when you have capsaicin or chili. And it's used in like chili peppers or anything spicy. And then you have the Scoville scale to measure how spicy things are. But for some people, instead of just having that hot sensation, you have a euphoric and pleasurable effect, which is why people like spicy food in certain cultures. Capsaicin, surprisingly, is also used in medicine, specifically for treatments with nerve pain, such as arthritis, psoriasis, and they use the like methodology. So something nerve pain is hot and like burning pain, which means that they use a hot burning spice to balance out that pain and cancel it out. Surprisingly, capsaicin is banned in equestrian sports for its hypersensitizing and pain relieving effects. And in the 2008 Summer Olympics, 4 horses were disqualified for testing positive for capsaicin.
One thing that has come up often in cooking across the internet recently, I've noticed, is people questioning the importance of the bay leaf. Um, in lots of recipes, you may notice that they'll call for a single bay leaf, which seems trivial, especially lots of like pot roasts and like um, typically dishes containing beef and that are often slow cooked. Um, so the bay leaf contains a compound called eugenol, which on its own has a pungent, spicy, a really strong, pungent, spicy flavor. Um, and you can see on the diagram to the right the hydroxyl group to, or the hydroxyl group para to the propyl group, along with the ester coming out of the aromatic ring. So something that kind of speaks to the strength of the bay leaf is just the quantity that you would generally see used in a dish. You're generally only going to have 1 or 2, depending on the recipe size. But along with kind of providing those stronger flavors, it also has certain medical benefits, such as aiding in digestion. It provides certain antifungal properties, certain anti-inflammatory properties, and is actually used in certain dentistry, or there are dentistry applications of eugenol specifically to treat toothaches and pulpitis, as they're due to the antibacterial and anti-inflammatory and certain sedative properties. And another compound that's very important to developing a stronger, kind of deeper flavor is MSG, or monosodium glutamate. A lot of times sometimes whenever you make a dish, like you'll notice that something is missing, but you can't quite put your finger on it. And a lot of times that is that umami flavor that MSG brings to the table. No pun intended. So the umami flavor comes from certain amino acids, and the most prominent of those being glutamate, more specifically glutamate in its ionic form, or glutamic acid. But even in that form, it doesn't typically provide that flavor. It needs to be in the salt form, such as monosodium glutamate, and it binds to certain taste buds or receptors on taste buds, which cause more saliva to be produced by the body, which aids in digestion of the proteins that often accompany it in foods.
And a quick note on umami. It actually, a lot of people don't know what that means, but it's pleasant, savory taste. So it's like brothy or meaty type of flavor, whereas like the other ones were like salty, and we obviously know what that is, but umami is the brothy or meaty taste, like in Parmesan cheese or miso soup.
So that is our presentation. Thank you for tuning in, and we hope you have a great day.